In this question, we had to calculate the ratio of I1 and I2 as shown in figure for 3 different cases of external resistance. So for solving this question, first of all we must simplify the circuits. In series circuit, if the two EMF batteries are in series and with the same polarity, then the net EMF will simply be the sum of the two EMF, that is 12 volt, with an internal resistance again in series, so it will be 2 ohm, with an external resistance of capital R. Let's say current I1 is flowing through it. If we talk about second circuit, that is this, then in such a kind of circuit, that is parallel circuit, net EMF is calculated by the formula summation of EI by RI divided by summation of 1 by RI. The EMF of the battery is given by EI and the internal resistance of the battery is given by RI. So in this case, if we have to calculate the net EMF, then it will be 6 by internal resistance 1 plus 6 again by internal resistance 1 whole divided by 1 by 1 plus 1 by 1. So it comes out to be 12 by 2 gives me 6 volts. So simply I have a battery of 6 volt EMF with an internal resistance of 1 by 2 ohm, because these two resistors are simply a parallel combination and our circuit reduced to this format with an external resistance capital R and current flowing through it is I2. Now let's solve the problem that we have to current I1 and I2 in each case. Let's say first case when capital R is 0.1 ohm. So we have V is equals to IR, potential is 12, current we have to calculate I1, R is 2 plus 0.1, so let's say I1 is given by 12 divided by 2.1 ampere. For second figure we have potential is 6, let's say current is I2, net resistance is capital R, that is 0.1 plus 0.5, that is 0.6, so I2 comes out to be 6 by 0.6 ampere. So I1 by I2 is 12 by 2.1 into 6 into 0.6, which comes out to be 0.57 amperes. In second case we have capital R as 1 ohm, so 12 into I1 into 2 plus 1, so I1 is 12 by 3 amperes. In second figure we have 6 volt connected to a resistance 0.5 plus 1, that is 1.5, so I2 comes out to be 6 divided by 1.5 ampere. So in this case I1 by I2 is 1 by 2 ampere. In third case when resistance is 10 ohm, so we have current as 12 divided by 11 amperes and I2 as 6 divided by 10.5 amperes. So if we take the ratio of I1 and I2 over here, we get answer is 1.75. Now what we have to note is that in order to get more current from a combination of two batteries, they should be joined in parallel if the external resistance is small, and in the series if the external resistance is large as compared to internal resistance. Now let's say in first case we have internal resistance that is less than the external resistance. So what is happening is we are getting more current from I2 than I1, so we must use a parallel combination. But in last case when the external resistance is larger than the internal resistance, then to get more current we must use series combination because I1 is greater than I2.